Hey, Probstats kids, this is Dr. Callahan with week 13 Tuesday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for week 13 Tuesday's warm-up log. All right, so you will need to have 2 guided notes today, and the first one looks like this, and the second one looks like this. So first one, and then second one, and we're gonna go over this together. All right, let's go ahead and take a look at this then. So I'm going to start off right here on the very beginning. I want you guys to go ahead and take a moment and read the objectives as to what we're doing today. All right, now we're going to go ahead and continue with this. So Euler, I know it kind of looks like Euler, but it's pronounced Euler, is referred as the Shakespearean of mathematics and the father of graph theory, whose collective work and creative output outnumber any mathematician to this day. The beginning of graph theory started off with the medieval town of Königsberg, Eastern Europe in the 1700s. And the puzzle was that, can you walk around town in such a way that you cross each bridge once and only once? And as you can see, there are 7 different bridges. That's right, they're highlighted in 7. And as a result, an intrigued Euler solution lays the foundation of a new branch of mathematics called graph theory. So I want you guys to go ahead and just give it a try and see if you're able to cross all 7 bridges without revisiting any of the bridge. And you can start anywhere you want. So if I want to start right here, I'm going to go this way to the Shopkeeper's Bridge, to the Green Bridge, Guts Giblet Bridge, over to the Blacksmith Bridge, and to the Wood Bridge, and now I'm stuck. Okay, so you can try a different way and see if you're able to get to there. But ultimately, the answer is no. There's actually absolutely no way of you doing that. Therefore, we came to Euler circuit's problem. The routing problem is finding ways to route the delivery of goods or service to an assortment of destinations. An Euler circuit problem is a specific type of routing problem where every single street or bridges, highway, etc., must be covered by a route, and this is called the exhaustion requirement. For example, a common exhaustive route problem is like mail delivery, police patrol, garbage collecting, street sweeping, snow removal, parade route, tour buses, electrometer reading. There is so many things that we have every day in our regular day that has contributed to Euler's contribution to mathematics. All right, so let's go ahead and take a look at this part here. So what I want you to do is, the mail carrier starts the in post office. She must deliver the mail on every single street. There are houses on both sides of the street. She must walk that block twice. She would like to cover the neighborhood with the least amount of walking. So using your pencil, go ahead and trace which route do you think she can go with the least amount of walking. So as you can see very quickly, you run into overlaps and deadhead travels where you're going to be like going back and forth and retracing the same path twice. And you don't want to do that because that requires more walking. So in plain English, lines connecting points, the graph we discussed in the chapter, have no connection to the graph function we've discussed in algebra. All right, so then we talked about vertices, edges, loops, multiple edges. For example, the only thing we haven't talked about, like edges, for example, is like AB or BA. Like back in geometry, loops are edges connected to a vertex itself, like B and B, because it goes around in a circle. Multiple edges are 2 edges connecting the same pair of vertices, like CD, for example, and DC. Isolated vertices are vertices not connected by any edge. For example, F is an isolated vertex. And vertex sets are like all the little points you have here, like, for example, F, A, B, C, D, and E. And the edge sets, you want to put them in alphabetical order, like E, B, or B, C, B, E, B, A, A, D, D, E, C, D, B, C, etc. All right, let's go over to this side right here. Why are graphs useful? They tell a story on a simple picture. So for example, friends at a party, and also the Euler's bridge problem. Notice that the land are the vertices, okay, so with a specific routing. Who has the most friends? Who has the least friend? This is basically something that you can do. You can say that, for example, Meg has 1, 2, 3, 4 friends that she know of, or like 4 connections. Betty has 1, 2, 3, 4, 5. So go ahead and do that with all of them. Veronica has 1 friend. Reggie has 2. Ginger has 4. Moose has 3 and Jughead has 2. And then also notice that 5 is an odd number. So make sure you label those. And these are the even numbers, E for even. A graph is just a visual representation of a set of objects and the relationship between those objects. You have a lot of freedom in how you want to draw a graph. So we want to do the graph because it's a lot easier to look and study than it is to actually look at the regular bridge problem. So then looking at this before, if you look at the original bridge of the Conan graph scenario, notice how looking at points like this and the path is easier and definitely easier to study. And notice that the land are the vertex and the bridge equals the edges. All right, so what I want you guys to do right now is redraw the points RALD in the form of a square. And I want you guys to go ahead and retrace its path. So it mimics the path that is drawn on the left side. An example of that will look something like this. Do the same thing over here to the bottom one. So redraw the points A, B, C, D, E on a linear path and retrace your path according to the original steps. So for example, if I start here at B, I go from B and I want to find the path. B, I'm going to go over down to D. So B goes to D, D goes to C, C goes to B, B goes to E, E goes to C. And if you actually draw this path here, so I'm going to go from B goes to E, E goes to C, C goes to, let's try this one more time. So B to E, E to C, C to B, so C then goes to B, B goes to D, and then D goes to C. And there you go. That's how you will create that. All right, next part. Adjacent, 2 vertices are adjacent, they're joined by an edge. For example, A and B are adjacent because they are connected by the 2 vertex. A and E are not adjacent, and E is adjacent to itself. 2 edges are adjacent, they share a common vertex. For example, AB and BF, and they share the vertex B. AB and FG are not adjacent. Degree is a number of edges that meet at a vertex. So degree A has 1, 2, 3. So there are 3 degrees in A. Degree B has 1, 2, 3, 4, 5. So that's odd. And then degree E has 4 because that's 1, 2, 3, 4. Vertices who are odd are A, B, C, F, G, H, and odd means it's 1, 3, 5, 7. Vertices that are even are E and D. Okay. So lastly, we're going to talk about circuits. A closed circuit is a trip along the edge of the graph. And the circuit starts and ends at the same place. So start in, same one. Path is an open trip along the edge of the graph, and a path has different endpoints. So the start and end are in 2 different places. All right, so now that we have that completed, we're now going to go ahead and move on to the next piece of class today, which you are going to be doing this piece here on Desmos. So let me go ahead and share the screen to the new one. So this is your one that you're going to be doing. I'm going to go ahead and assign it to your class right here. And then hit View Dashboard. And you are going to let's see, how do I get that? I'm going to give you guys a QR code so that way it'll be a little bit easier for you guys to get to. So let me go ahead and copy this. I'm going to switch this over to a QR code. And we'll go ahead and paste it on the screen here so that way you guys can use that. And essentially you have several questions over there that you're going to be working on. So your QR code is right here. And I also want to make sure that I put this on a tiny URL so that way you're able to access it in case you're using your cell phone the same as the device you're going to need for the QR code, obviously. So here is your tiny URL. And just make sure you guys work on the problems. And there are 16 of them. So this is actually the first page. Hit next and then type in your response here because it's giving you several scenarios. All right, you guys, that's basically it of what you're expected to do. So I highly, highly suggest that you guys go ahead and complete this. And other than that, I hope you guys have a wonderful week. And as always, I will see you guys next time. Take care.